Hello, Legacy students. So today we're going to write polynomial functions based on some descriptions we got. What you're going to want to have on you today, your notes, calculator, and then a pen or a pencil. So today, if you recall, when we looked at graphing quadratics, we had what's known as intercept form, which looked like f of x equals a, which was some number, and then x minus p and x minus q. Remember, P and Q were our intercepts. Well, in this section, what we're going to look at is how to write equations of cubic functions. So you'll have to add another factor. So we're going to have f of x equals a times x minus p times x minus q times x minus r, where p, q, and r are x-intercepts of the graph. Let's take a look at a couple of examples so you get an idea of how to do this. So, on this one, I have a graph here on the left-hand side, and I need to leave my answer in factored form. So you do not need to multiply this out to get an x cubed function, which is super awesome. So on here, it looks like I have x-intercepts at -3 here, one at 1, and one at 4, right? And then I have this really random point right here. We want that random point. It's going to be useful for us. So first things first, let's remember our equation here. Y equals a times x minus p times x minus q times x minus r. So now what I can now do is take my 3 x-intercepts here and plug that in for my p, q, and r. Now notice, guys, that it's basically however you would have solved to get that -3. So it would be x plus 3, because if I'd set that equal to 0 and solve, I would have gotten -3. So you're always going to want to put in the opposite into your parentheses when you make your factors, okay? Now, how can I get that a? Right now I have 3 variables, y, a, and x. Well, x and y are usually missing. We don't have usually a number for that, but we need a number for a. So that's when that random point's going to come in here. So I'm going to take my random point and plug in my 0 for my x and the -4 for our y. So I'll have -4 equals a times 0 plus 3 times 0 minus 1 times 0 minus 4. Now it becomes a simplification problem. So let's add each of the parentheses together. So I get a 3, a -1, and a -4. Then multiply everybody together. I should get 3 times -1, that's -3 times -4. We should get positive 12, right? Still solving for a though, so divide by 12 it looks like. I'll get -1/3, right? Because if I divide by 12, I get -4 over 12, which is -1/3, right? So now what I'm going to do is take that -1/3 right here and put it up there. So my equation for my cubic function in factored form, because it would be silly to multiply this all out, I will get y equals -1/3 times x plus 3 times x minus 1 times x minus 4. Let's try one more. So I just have some given points here. Leave your answer in factored form again. So I have -2, 0, 0, 0, 1, 0, and 2, 1. So very first thing, you're always going to want to figure out who's the intercepts and who's the random point. So the random point is 2, 1, of course, because it's not an x-intercept. So my x-intercepts are -2, 0, and 1. So now let's go ahead and plug it into our formula. Y equals a times x minus p times x minus q times x minus r. And remember, guys, it's going to be opposite. So instead of being x minus 2, it's going to be x plus 2, right? Then x minus 0, which is basically just x, but nevertheless, we need to have that -0 there. And then x minus 1. So now let's plug in our random point for our x and our y. So my y is 1. My a is, I still need to find my a. Then I have 2 plus 2, 2 minus 0, and 2 minus 1. Do the math really quick here. So 2 plus 2, we're going to get 4. 2 minus 0 is 2, and 2 minus 1 is 1. Let's do multiplication quick. 4 times 2, 8 times 1, that's 8. And then it looks like I got to divide by 8. So we'll get 1/8 for my A. So just like last time, we're going to take that 1/8 and whoop, put it right here. And you could write this two ways. So I could have it 1/8 times x plus 2 times x minus 0 times x minus 1. Or if that x minus 0 bothers you a lot, which for some people it does, you can not have the x minus 0. You could just have a plain old x sitting right there. And then it will be fine and perfect and dandy. And that's the end of this video. See you later, Sabers.